So again, TypeBox making APIs reliable. And we are talking about TypeScript here, because most of us that are working with Node.js in a corporate setting are working with TypeScript. And we'll delve into this first. So we will first talk about, okay, why do we need something such as TypeBox, for instance? But then we will go into practical examples quite fast, so you don't get bored or anything, that you will see something that is very practical. And just to give you energy, I will soon show you something much more than TypeBox as well. So some of you might not have seen this before. For some of you, this is something you do at work every day, so the reaction might differ. It should be said also that TypeBox is a library for TypeScript. There are alternatives. There is something called Zod that many people use. I haven't used that, so I will not be able to give you, an answer. So what's the difference, or why is this better than that? This is basically what I got into in one of my projects, and that's why I'm going to share the things that I found. So, okay, let's start about this. So I already use TypeScript. Why should I need TypeBox? Right? That's a very normal question to think about. We already have types in TypeScript. And to answer this question, we have to think a little bit about what TypeScript is. It's a little bit of a special language in a way, because the way TypeScript works is that, this is a bit of an analogy, but when we are doing some work on a building, we put up a scaffold, right? We put up something near the building so that we can access and do the work in a structured way and such. But then when we are finished with the building, we remove the scaffold. And likewise, when we are compiling TypeScript, first the compiler is checking that everything is all right, the way we intended it, that all types match and such, and then all the types are wiped. And you might know that in one of the later releases now of Node.js, I think it's like 1.5 months ago or something like that, they actually have a mode inside Node.js itself, so it can strip TypeScript, the superset of TypeScript. So TypeScript is actually just a little bit more syntax on top of normal JavaScript. And if you strip that away, you have the JavaScript left. And that is what is happening when we are compiling, after the checking. Okay, so let's think about it now. So we are removing all that type information. So what happens? What happens is that if we would like to query about that, it's not that obvious how to do that inside the JS, inside the runtime. This information is gone now. It's been stripped away on purpose. In other languages, this has been addressed in different ways, like runtime type information. There is in old Delphi, for instance, it's a very esoteric old language, but there they have runtime type information. So you can say with special instructions that you want some of this information about the types to kind of be left there in the program so that you can talk to this information from your program. So, similarly, if you have been programming something with Java or C# or similar, there is something called reflection, which is basically the same thing. To be able to, from the program can now talk about the types, which of course in TypeScript would not be possible because we have stripped the types away. So that's why we need some bridge there. To kind of hammer this point home here, some of you that have been on this meetup several times, you will maybe see this thing that I often show. This is a very useful tool, even if it's very simple, to talk about like the basics of a program from its like primitives, completely, what is a program, right? A program is basically that sometimes something comes in, something is happening in our program. So this is our program, and then something goes out. And almost any program on Earth is actually this way. But when it comes to APIs, then it's quite obvious for us because we have a request. So we are, sending something in, something is happening, and something comes out. So it's quite easy to talk about this. Now, what TypeScript can help us with is all things that happen in the process. All that is, safe, right? Because it's our types, and that's checked while compiling. The output data is also kind of safe because everything we push out from the program is based on the types that we built while we were building the program, so we don't have to worry about that. That's cool. But what about the data that we take into the program? Is it safe automatically? No, it isn't, and I will show you the first demo to just demonstrate this, this point. Right now, I have in my latest projects I've been working with, I've been using Fastify. It's a little bit more modern than Express.js, but yeah, it's not that different. So you will probably pick it up even if you don't know Fastify. The point here is that we are importing Fastify and we are using a user. So we are using the type system of TypeScript. And then we have app post endpoint. This is very similar to what you would do in Express.js as well, right? You have API users. This is the endpoint that we will be implementing, and this is the implementation of it. This is just, you can almost forget about this. This is just the startup of the Fastify, as usual. So what is this endpoint doing? It has one thing that is can drink, and it just checks that the user age is the same or more than 21. And then it creates kind of a greeting, and it returns a combination of the whole user data, can drink, which is a boolean, and the greeting that is constructed. So let's see what happens when we start this up. Now we have no type checking whatsoever, more than we have TypeScript. And you see also that, I mean, user here is the body that is expected to go in. So from the perspective of TypeScript, we are like expecting the user to come. So let's run this. And it's kind of hard because I have some zoom controls in the way, but I will soon fix this. So yeah. First of all, we will try with some real data, some data that is corresponding to the data that we had in the struct. So we will just run this first just to see that the endpoint is doing what we are expecting. And we are seeing that we got 200 OK. And we see that we have, you know, the user is returned the way we send it in. We have the greeting and can drink. Yeah, obviously, I can drink. I don't even have to show ID anymore for a long time. But the interesting thing is for us, what happens when we send in something stupid? Because we said that we are expecting user on this endpoint, right? But now we are sending in something else. We are sending in an ID that is a string. The name is a number here. You see the email is completely malformed because it's coming as an object here, and then you have something inside, and then you have an age that is not a number. Yeah. So let's try this one out and see what happens. And what we get is something that we should all be very ashamed of if we are programming APIs professionally. We get a 500 error, which means that there is a, you know, unhandled stuff in our program. This should really never happen to us. And this talk is about kind of getting rid of this problem from the perspective, at least, of the data coming into our program. So let's see here. So the first example, this is what I showed you. And oh yeah, I wanted to show you, this is also very important from a programmer's perspective. I actually put a breakpoint here on the handler. Now we'll stop this one now, and we will start it in debug mode. And I will run this wrong request again. So we'll see what the program is actually doing. So yeah, first it stopped on the first line. That's no problem. But then let's see here. Okay, so second line is this string 21 is compared to the number of 21. What happens here? Oh, we press F8 and it goes true. It says false. So this is actually, and I want to emphasize this so that you think about it. This is much worse than actually the 500 error. This is that some data that is completely false came through the program and might just run through the program and continue and even return a 200 OK, potentially, while still being completely false, while still being, you know, stored maybe in some system and such. And then when we press for the next line to run, we will see that, yes, we got the 500 error. And the error is, of course, that the username, which we sent in as a number, does not even have a method that is called to uppercase. And this is what crashed this endpoint. OK, what can we do about it? Let's just do the simplest typebox check. Just try to use this library typebox to fix this problem that we have here in the simplest way possible. No magic. So we have my next example here. And see if I can. I'm afraid to do full screen here because those controls might do that I cannot regain control. So I will do this instead. I guess that you are seeing enough here, right? Is it okay? Yeah. So what we're doing here is that we are using Typebox now in addition to Fastify. And then we are initializing it. And then we have the same user we had in the first example. But then on top of that, we are using, you see, type is what we took from Typebox. So we are creating something like a Typebox user, TB user here, that is the same structure as here, right? And then we are modifying slightly the endpoint so that the endpoint is using a schema that is the TB user, right? Everyone with us here? We are pointing to the type that is from Typebox. And what is the magic here? Well, the Typebox user, as you see, it's kind of a construct. So this is created even when the program is running, right? It will be there. So let's see what happens. When we stop this, we restart example 2. And then we can try out, of course, the correct one. That works as usual, but that worked before as well. Let's see what happens when we run the request that is wrong. Now, what do you think? We get a 400 error. That is completely correct for an API to return. We have a bad request. On top of that, we get an information about everything that is wrong that was sent in, one after another. So it's not like you have to do the play game where you are like fixing one thing and then you get information about the next and such. You just get all that is wrong with it. You see that the body ID is expected a number, the name is expected string, and so on. It tells you what it's expecting. So already we have a huge improvement. But what is the problem now if we are going back to the source code here? What do you think is kind of problematic with this section? Anyone has an idea? Yeah? Very good. That's exactly what I wanted to point out. We don't really want to update or keep track of two definitions of the same thing, right? And then we add the field to one and forget in the other. That's completely useless, actually. I just wanted to show you what Typebox does. But let's see if we can get a good implementation so that we can get both features. We don't have to do it duplicate this. Oh, actually, on example 2, I wanted to show you one thing more. Note that in example 2, we are saying that we have the schema. We are actually telling Fastify that here you have the schema. So I want to show you the schema of Typebox that it has created. Do you guys know what the JSON schema is? Hands up for those that know. Okay. So several know. For those of you that don't know, it's a description language. So it's a JSON document, but it describes how another JSON document should look when it comes to types and everything. So that's what we will be looking at. And now we will just check example 2b. It's just a quick run. We just want to show you the, whoops, not what I intended. When we print out what is in the TB user that we created in the Typebox user, we see that this is the schema. And the interesting thing is that Typebox That's just one library, but schema is an international standard. So regardless of language, Java, Go, or whatever, they will also talk about JSON schema, and there will be libraries supporting it. So at once we have something that is very useful that we can share with others. So that was what I want to show you from that. And that's also the point here. Fastify doesn't really know about TypeBox as such. It just gets the schema, and that's enough for it to validate in this case. The next thing is, okay, so using TypeBox type with TypeScript. That's exactly what you alluded to, right? We want to have just one type that we are working with. So can we do that? That's the next example. So let's take a look at this one here. So yes, now I'm not calling it the TB user anymore. It's not the TypeBox user. I'm actually saying that this is the user schema. But as you see, it's exactly the same thing. Is clear? So what TB user was before in the previous example is now the user schema. And now is the kind of magic trick here. The magic trick here is that if we do like this, if user DTO, most of you probably know that DTO is the data transfer object. So what we are doing is we are defining a type that is a real TypeScript type, and we are doing it like this, that we do static, and in generics we say type of the user schema. And magically, the compiler understands everything now about this guy here. And in addition, it works in all our programming environments, like in VS Code, I'm using WebStorm. So if we go down here and we go to like the user, press Control space, it shows up everything that we are expecting. It knows about this type. So now we have fixed this problem, right? We can have just the user schema, and it still works inside our environment, and it works in the compiler, it understands it, so we can just define it once. Very important thing. I'm not suggesting that we should do TypeBox types for any type in your program. That's completely useless. You remember when we were talking about this flowchart of every program? The rest of the program, what happens inside the program, all the objects and stuff you do there, and everything you output, that is fine that it's in TypeScript. You don't have to do anything about that. But we are talking about the things that are coming into your program. Of course, this is transferable to any kind of data that is coming into your program, even if it's not an API. But in this case, we are talking APIs, right? So anyways. Okay, so now we have done this, and I think that you can trust me that this actually works. Now I will go to this thing that I want to give you something much more than just TypeBox, because now we have the basics for TypeBox, and we should all be able to. You will get the URL that you can scan on your QR code afterwards to the project, and you can all use it, right? It's not that strange. We are just defining types in a little bit different way when it comes to the things that are coming into the program. So I will show you the kind of bonus that was not even in the title here. And the bonus is Swagger. Anyone heard about Swagger? Swagger. Most of you have heard about Swagger. Are you using Swagger? Yeah, so many people are using it already. But those of you that haven't, I will show you something cool now. So I have the example 4. I will start it first. I will go through the code afterwards because I want to show you what it actually is. If we start this program now, you will see an interesting thing, and it's that the program, I will show you why soon, but it's running at 3000 as usual, but we also have a new endpoint that is /swagger. You can actually change this to whatever you want. I usually use Swagger to be sure what it is. I added Swagger, and it's connected to TypeBox, so it's kind of there for part of this talk. Now we go to Swagger. And what do we have? We have some kind of a graphical interface, but you have the post request here. And this is the one that we have just defined into Fastify, right? And if we click here, you see that we get quite a lot of information. We get information, for instance, about this type that is expected. It's coming from TypeBox because of schema. And we also get information about the response. For this to work like I have done it here, we have actually to define the response type as well. But anyways, as you see, it's quite cool. It's already kind of a description of our API. And in addition, Swagger allows us to try it out. So we can actually use now the browser to test this API. So let's say that I clicked try it out, and then I get this default body here. So let's just put something in. Name, I do Matt, and then I have e@g.com, and we have age 40, for instance. And I do an execute. And what happened? First, we get the whole curl, how we would run this from the command line. But we also get the whole, what happened here. We get the result code, and we get what we got out. And this is all part of our web application now. So it's quite a cool thing to get by defining the types in TypeBox. I'm thinking that at least. So it's a big, like a bonus. And we can also, of course, try out if we do something stupid. Then we can get like this, and we do an execute. And as usual, we are seeing that we get a 400, as we are expecting now, that we are handling the types in the correct way. And also we get what field was wrong when we are doing this. So let's take a quick look at Swagger, the implementation of Swagger here, what we needed to do to get all of this together with this type that we defined. We have the user schema, that's the same. That's only one of them. Then we have this static definition that makes it so that TypeScript sees it as a type inside our program. Then I defined, just for the Swagger picture or UI to be nice, I defined the result type as well. And that's exactly the same that is returned from our handler for this endpoint, right? You remember this. It's like the greeting and if can drink and whatever it was. So we have the definitions of input and output in this case. We have, and since there are several things that are happening in the startup here, I actually defined a method for start server. So we are registering in Fastify the two schemas that we will be using. Then if we look at this here, you see that I'm adding Swagger and Swagger UI. So these two together add the Swagger. Much of what is written here is, of course, just extra nice text so that the UI contains some sensible data, because we are starting to now document the API. So you actually don't need all this. But I added it so that we get the extra data. Also, I want to point out one other thing. You see that I'm doing like an ugly import here, right where I'm using it. I'm doing the import, and then I'm using the Swagger at once. And the same with Swagger UI. The reason for this is that many of us don't want to have the Swagger interface as, when we are putting something into production, right? We might not want the Swagger endpoint to be there. So then you can just put a big if statement around this, and then none of Swagger will be loaded. So that's just, a practical thing that you can use. And then after that, we have the normal endpoint as we had it before. The logic of it is exactly the same, and we just added a little bit of more craft here for the API description to be a little bit more talkative. But basically, the important part is still schema body, user schema, and that's what we have been seeing since the examples before. Now, I come to this, what I wanted to show you, because, okay, first of all, you don't have to type all this for every call, right? You just put it in there, and what happens then? Well, we have the post handler, as we have had all the time, and now I will add, let's see here, because let's do it with the Swedish keyboard. I'm adding a get endpoint on the same URL now. And we will just return some dummy users on this on this endpoint. But the point is here that, let's see, like this. The point is that we are referring again to the response. You see, type, as you remember, that was from TypeBox. We are saying we have an array of user schema. So we are just saying, okay, so what will this endpoint return? And we are saying it will be an array of users. Might be empty, might be something else, but it's an array. And if I now stop this program and I restart it, like that, and we go to Swagger, bam, you see that the get endpoint is already there. So you see this is kind of a big bonus, that you just add endpoints basically the same way. Of course, you have to define the types and such, but you just add endpoints the way you usually do, and they end up in this specification as it is. So Swagger is actually kind of the tooling to something that is called Open API. And I know that there are several like new things here. We are talking about like TypeBox, we were talking about JSON schema, right? And now we are talking about Open API. So Open API is a standard to define APIs as such in a language agnostic way. And Swagger is the tooling for this. So if we click here on this link that is available in Swagger, we will get the JSON description of this API as it is. If we copy this, now let's see. Now we'll show you, if you go to your Google Swagger editor, then you will see that you come to a page that is somewhat similar to the Swagger we had in our application. Okay, there we go. So they have some, let's see. If I remove everything that is here, and we have the Swagger editor, this is available online, you can just Google it and go there. Then you can take whatever we had here in our Swagger UI. Again, I have this problem with Zoom tools. Just a second. Yeah, here we had this link that we clicked in our Swagger UI. We can copy that, and we can go to the Swagger editor, paste that. Okay, so we have JSON, it wants YAML, that's okay. But we see that we have this API that we, as it is right now, and when we add methods to it, we can get it in here as well. And inside the Swagger editor, you actually can generate both servers and clients. You get kind of, you know, a skeleton for your project. So that's super cool if you have a customer or something like that that wants to get started using your API, and they are using maybe a completely different language. Maybe they are using like generate client, let's see, maybe they are using Go or they are using Java or something else here. They can just click here and bam, let's see that I'm just clicking on Ruby. It already downloaded a generated client for this. Additionally, of course, if we go back here and we go to users and we try it out, so we see that we get those fake users that I created. It's a 200 response. Everything is working as it should. And of course, as I said before, you have a curl here. So there is yet another page that is really, really cool online that is called curl converter, that you can also Google it. And curl converter is basically you paste any curl, and then you just click any language that you want to have a basic implementation, because what you get from the Swagger editor is actually kind of a zip file with a whole project or something. But here, if you just want it up and running in your favorite language in like 30 seconds or something, then you can go here to curl converter, copy this curl, and just select the language. Okay, so in Go it would look like that. You just create a main.go, paste this info, and start the program, and it will access this endpoint. So that's pretty cool as well. C# like this, and so on. Yeah, so Swagger, we talked about that. So summary is use TypeBox, or maybe I should say, or similar. such as Zog is probably very good as well. Use something to check your incoming data because TypeScript does not do it. And then use Swagger to get an open API spec for almost free. Yeah, you have to add a little bit of metadata, but you will get a spec of your API. And regardless of open source, if you're working in a company, how awesome is that to just give your customers or users something that is usable regardless of what they are doing? So yeah, that's basically it. Thank you so much. That was the talk.